Alright, and we just keep expanding what we have been doing, and at this point we want to work with linear equations that have fractions in them. And that's going to require a little bit of review on adding and subtracting fractions. So look at this simple problem. We want to add 2/3 and 3/8. And what we want to do first, take a second and see if you can remember. Yes, hopefully you remembered. We want to get a common denominator, the smallest number that both 3 and 8 go into. And that number is 24. Now, what I do is I ask the question, what do I multiply 3 by to get 24? And you should be able to understand that the answer is 8. So that's what I have to multiply the 2 by, and that gives me 16. And then I ask the same question here, what do I multiply 8 by to get 24? The answer is 3, and that's what I multiplied this 3 by also. So that gives me a 9. And so what I wind up with is 25 over 24. Let's try one more. Okay, so I look at the two denominators, 4 and 12. And what I'm looking for is the smallest number that both 4 and 12 go into. In this case, it's actually a little bit easier. The denominator is 12. So I say, what do I multiply 4 by to get 12? And the answer is 3. And that's what I have to multiply the 5 by. So that gives me 15. I've already got a 12 on the bottom here, so I leave that alone. And this is 8 over 12, which I can simplify to 2 over 3. Alright, so that's a little bit of review. So let's take a look at this problem. And when you kind of just look at it just a little bit, what you notice is that we got only x's on one side. We have only x's on one side. And we have numbers on both sides. So to simplify it, I have to add 5/3 to each side. Okay, so now what I'm doing is simply working with fractions. And so what I want to add is 3/7 and 5/3. I see that my denominator has to be 21. And when I add these together, what I do is this 7 got multiplied by a 3, so that gets multiplied by a 3, which is a 9. This got multiplied by 7, so this gets multiplied by 7, which is 35. And so what I have is 9 plus 35. So I'll rewrite this as 2/3 x equals 44 over 21. Now what I want to do is multiply each side by whatever it takes to get rid of the 2/3. And that's 3/2. So at any point while I'm going through one of these problems, it might help for you to just press the pause button and try to think about what you would do next and see if it seems to be correct. And so now what I get is simply x is equal to, okay, what happens here? Let's see. 2 goes into 44 22 times. 3 goes into 21. 3 goes into 21 7 times. And so x is equal to 22 over 7. And there we go. So that's a problem that involves fractions. So let's take a look at this one. It looks pretty crazy, but let's remember our basic strategy. We want to simplify each side completely until it just has terms involving x and constants. Separate the x's and the constants. Multiply by the reciprocal of the coefficient in front of x. So we'll begin by simplifying. Looks like it's only the right side that needs simplifying. So if I rewrite this, I have 7 over 6 minus 4/3 x equals minus 3/2 x plus, what do I get? 2x plus 2 times 3 over 2 is just 3. So now I have to add together on the right side, and I have to simplify minus 3 halves and 2. And at this point, if I do that, 7 sixths minus 4 thirds x equals minus 3 halves plus 2x. 2 is the same as 4 over 2, and so this just becomes 1 over 2x plus 3. So now what I've done is I've got all my x's and constants completely simplified on each side. Now it's time to separate. So let's see, what am I going to do here? I will add 4 thirds x to each side, and then I want to get rid of the 3 over here, so I'll subtract 3. Okay, so take a look at these fractions that I have to add and subtract now. 7 sixths minus 3, well 3 is the same as 18 sixths, so if I do that subtraction, I get minus 11 sixths equals, now if I look over here, I have 1/2 x plus 4 thirds, and so in terms of simplifying that, this is 3 over 6, and this is 8 over 6, so what that gives me is 11 over 6x. So take a second and check the math on that. So now I have to get rid of the coefficient, which is simply the number in front of x. So I'll multiply by 6 over 11. 6 over 11, and look how nice this works out. So x is equal to minus 1. Wow, who would have guessed that from the beginning problem?